you may need paper here, okay?
I do it in my notebook.
Got it. So you can show the work, and I recommend it. However, for number 3, you don't have to. But
Yeah.
number 1, I think you may want to write something like this: expansion, and then just do the math, multiply it. Number 2, I think that's 1/2, right? Yeah. So it's 1/2 to the 4th.
Yeah.
You can show the expansion. You don't need to parenthesize it if you don't want, but you gotta make it very clear. But you cannot do it too far. You see, like number 1, you could still do it. Number 3. You could do it for number 3, which is 1 to the 8th power, but you don't have to. Okay, this one multiply 1 4 times straight across. That's just still 1. 8 times 2 is 16, so that's the answer. 15 times 15, you want to go back and do the work to show it. But 1 to any power, you don't have to expand that like 1 1 1 8 times. Just write 1 because it will turn into 1. I think you're okay with that. No, yeah, your teacher will be accepting the answer being just 1. You don't have to show any work for 1 to any power. 99th and 1 to the 99th power is still going to be 1. 2. Wait, let me double check. Okay. Yeah, you have to multiply it. You have to get the answer. It says write each as a product as the same factor. Yeah, you know what? To satisfy the instruction, to make sure that you are following the instruction, you can just show like, hey, it's 8 times, but the answer is still going to be 1. I don't think you should for number 3. I don't think you should be doing this for number 1. Yeah, but it's still 1. But 2.5
it wouldn't equal 8
for number. Okay.
Oh wait, I did. Yeah, never mind. I did my math wrong.
Okay, do you see it? Yeah. Remember, anything to the power, you multiply itself as many times as the power says so. So that's why it's still going to be 1. Careful. Yeah. Had it been 1.8 or 8.1, then it would be 8. Yeah, but I get the confusion. So, but this one, you want to parenthesize it to show that this is the math that you're doing. Now, careful, don't add this up. You multiply 25 times 25, and then move the decimal, and then times 25 again. Is that okay? Then move the decimal. Then find the value. Yeah.
12.5. Wait, 12.5. Yeah.
Well, which one?
2 halves times to the 3rd power.
2.5 to the 3rd power. Okay, what did you say the answer was? I can check right now.
12.5.
I'm sure it's right.
Oh.
Actually, no. Yeah, you gotta multiply it. Let me show it like a little bit of work here. So you want to do like 2.5 times 2.5 normally, right? Like this. Let me expand it. But then you have to take the answer from there and multiply it again. For example, 5 times 5, 25, carry 5 times 10, 12. Like this right now. Oh, don't move the decimal. Just go ahead and continue. 5 again, carry 2, 10. 5 times 2 is 10, carry 1, 2 times 2, 4, 5. So the answer right now between the 2.5 and 2.5, just a pair. So bring it down to 6, move the decimal 2 places over like this, and then you'll take the 6.25 times 2.5 again. See how that works? Yes.
Yeah. Okay.
And then you'll get that answer. But don't forget, multiply everything normally. Wait. Let me align the digit. Don't align the decimal in this case, right? Align the digits like this, 5, 2, align them, and just multiply it normal. But when you get the answer, move it 3 places over from the right. Is that okay?
Yeah.
Okay. Unless you want me to continue there, but I think you're good. Okay, let's see number 5. Okay, 1 second here. All right, let me see. Population. Okay. One of the world's smallest countries, Vatican City, has a population less than 10 to the 3rd people. Okay. About how many people live in this country? Well, you want to show the work here. 10 to the third is 10 times 10 times 10. There's a shortcut. If you ever have 10 to any power, this is actually something that a lot of students can do really quickly. And in science, it's quick. 10 to the third is exactly 10, I'm sorry, 10 to any power will be exactly 1 and as many zero as the exponent says. No kidding. So here's the answer. But if you want to show the work, you can still do it. This is something that everyone knows. If and only if 10, only 10, nothing else, 10, not 100, just 10, raised to whatever power, the answer will be 1 and as many zero as the power says. Like 3 zeros, there it is, third power, 3 zeros. But if you want to show the work, you can. So here it is, 1, 0, and then 1. But you have to do it again, okay? But let me expand it. 10 times 10 is 100. I think you can even write 100 first if you want. You don't have to show this work if you don't want. I don't think your teacher will care. But anyway, if you were to do it, you get 100 here. And then you bring that 100 and times it by 10 again, because it says do it 3 times. So if you were to do it, you get the same answer, 0, 0, 0, 0, and then 1. And then you add them straight down. Here it is. You put a comma if you want, okay? But it's not a word problem, so it should be okay with or without. So the answer is 1,000. We want to say people. Yeah. About, but you should write the word people as the unit just to be safe.
Okay, cool.
Okay, good. Now, number 6, order of operation. So yeah, you're working on this already and want to make sure that you do it correctly, okay? So like PEMDAS, don't forget, multiplied or divide first. So based on everything I'm scanning from 6 to 9, all you care is about multiplying, dividing first. Oh, parentheses too. So let's do the whole PEMDAS then, okay? Right now for 6. So if you do 6, I think that's add and then divide. Okay, so let me write it out. You want to divide first? I believe that's addition symbol, right? The first one? I think, okay?
Yeah, the first one
Okay.
is.
That means you will do this first. Just keep the 42 waiting in the front. So 6 divided by 2 is 3. And then you can add. So why are we doing that? You're not doing parentheses, you're not doing exponent, but you're doing multiplication, division first, and then add or subtract. So whatever comes first, multiplication, division, before adding, subtracting. That's why you divide first, because it comes before adding and or subtracting. Okay, anyway, 45, final answer. For number 7, 6, I'll write it out. I think that is also addition, right? The 64 plus parentheses.
So wait, yeah, you always do division first?
Or multiplication from left to right when you read like this number 6, you read it from left to right, whichever comes first, multiplying or dividing, doesn't matter. But number 7 is different. Yeah, in this case, division. I'm sorry. Back to number 6. You only have division before multiplication. So, but no matter, multiplication or division comes first. You do it first before you add or subtract. So based on PEMDAS, it's like the last 4 letters here. If you kind of follow that order, you come across D before A. That's why you do D first. Division before adding. See? Yeah. But number 7 is different though. Here's why. Because you now have parentheses involved. So you got to do that first. Here, have a look. So if you follow PEMDAS, this is my D, okay? PEMDAS, it says, hey, do your parentheses. What does that mean? It means that work whatever it is between the parentheses first. That means you subtract first. So you got to do this first. Now, I know it's like, hey, we were saying, hey, you got to do multiplication, division before adding, subtracting. But P is a mandatory thing. It's first. So you're forced based on the rule to do it. So whatever, it doesn't matter if it's subtracting or adding or multiplying, you're going to have to do them. So subtract first. What is that? 7. So the answer is 8 between the parentheses. So you're done with the parentheses, and then you copy everything around it, right? Like this. And then treat this row, as brand new problem. So I got my P done. So I'm done with P. I'll write my PEMDAS brand new every single time if you want. Okay.
Well,
So here, P is done. E, there's no exponent. E stands for exponent. There's no exponent. That means, wait, are you okay? This is what I got from here. But you got to copy everything else around it. Later on, you'll be able to do this much quicker or simultaneous work. Right now, I recommend you do it like one letter at a time and then copy everything around it back. And then do it again, like brand new, like start brand new. Okay, now you start again, brand new. P is done. And then look from left to right again, left to right for this row, right? You come across adding. No, don't do that. You see multiplication because you got to do that one first because of this right here. The last four letter, E, you don't have. You can cross that out. Multiplication or division comes before adding or subtracting. That's why you're going to do this next. Is that okay?
yeah.
So you do that.
Yeah.
So it'd be 16. And then copy everything else around it again, in front or behind. Exact same order, okay? Exact same arrangement. And then continue from here. Multiplication, division is done. Then add, yeah, then add. And then subtract. But add first, what is that? Let me see. It's going to be 80. Yeah. Subtract 2. Yeah. And then subtract. Then you're done. So that would be 78. Yeah. That looks good. Now, if you ever want to check your work, you can use a calculator. No kidding, but hopefully you have a scientific calculator, maybe something that looks like this. You can do it. Watch, just in case you really want to do this, okay? Because a lot of students actually know that they can do this, but you have to have a scientific calculator, the one that looks kind of fancy like the one I have here. There are many free ones out there. Watch, I'll punch everything in exactly the way you see it, and it will work itself exactly that. So here it is. Oops, something's wrong here. Double check is 15 minus 7. Yeah, everything's good, but let me see. Did I miss something? Times 2. 16 minus, did I miss it? Yeah, I put 9 instead of 2 here. You see that? I put 2 instead of 9. So careful, copy everything
Oh,
else.
I put it too.
Okay, so it is 9, and it is 9 here. Sorry. When I talk, sometimes I forget. That means the answer is going to be 71. Is that okay? See, I'm glad I checked that. Really glad that I did that. So it's 71. But everything else, it's exactly the work that you should be doing exactly the way I went through it. Is that okay? There you go. Good. This is a good problem. Okay, number 8. Same idea. So have a look. We're going to do PEMDAS again. I think is that adding? I think that's adding, right? 48 plus.
That's division.
Okay, that means, could you check number 7? 64, like 64, is that add or divide? Number 7.
Divide.
Divide?
Divide.
I'm sorry, we got to do this again. It looks like on my end here. Yeah, on my end, it looks like an addition. So, okay, that's fine. Let me erase that quickly. We'll do it again for practice. It's good practice. So I'll ask carefully. So it's number 7 is 64 divide, right? Parenthesis, 15 minus 7. Is that right?
Yep.
Like, right? Okay. That means you're still going to do your PEMDAS, your parenthesis first. So let's have a look for practice. Perfect. Let's do PEMDAS again. And I'll punch in the calculator. So here's the actual problem with the division symbol, right? Okay. So do this first, parenthesis, 8. And copy everything else around it in front and behind as is. Okay? Exactly as you see it. So far? Yeah. Okay, yeah. So erase all that if you copy my original work. Okay. So then you're done with parentheses. You don't have exponent. You can cross that out. Multiplication. Now don't cross multiplication out just yet. Because if you read from left to right, like this, right? You come across division first. So you're going to do that one first. When you come across M and D, A and S, okay, it means that you can switch them around, whichever comes first from left to right. So that means I come across division first. So I'm going to do that first. Okay. 64 divided by 8 is 8. So I'm done with that. And then I copy everything else around it. So I'll go ahead and do a wedge like that. Like this. my division is done. So I'm going to do my multiplication now. So 16 here. And then I bring down the -9. And then I do my only operation left, which is subtracting. So the answer should be 7. So watch, if I punch this in, it'll be exactly that. So I'll bring this back. All I'm going to change is the division symbol here in the front. Take a look. When I hit division, it'll be a slash. It's a fraction bar, by the way. So they're trying, we were trying to teach you guys that, hey, division is fraction. Okay, so here we go. And here's the answer, 7. You see?
Okay.
Okay.
Can I go blow my nose real quick?
Yes. I'll copy 8. Yes.
Okay, I'm good. Thank you.
You okay?
Yeah.
All right. No worries.
Sorry, still a little sick.
No, I get it. All right. Next one here, okay, number 8. So we're gonna do PEMDAS again,
Okay.
but this time the parentheses is like way in the back. You still should follow the rule. However, later on, I promise you'll learn to do this thing simultaneously. You can be doing this done like in the first row even, okay? But right now we're gonna follow the order, so your teacher will be more accepting of it. So parentheses, let's do that first. It'll be 2, but copy everything else around it, just like this. Watch, even the exponent, you're copying it around it. It's like just the parentheses is what you do, right? And then the third power is still lingering there, so you have to copy it. But then everything else in front of it too, like this.
Why wouldn't you solve it?
You
Like,
you can, yes, you can, absolutely can. Like if you do the 2, then raise to the third power will be 8. But don't forget, you still have other operation to do, so you can't do it in one shot. But like I said, later on, you will be able to do it. I promise. Right now, they're teaching you the order operation. So you kind of have to kind of go along with it, But you can't technically do this whole thing in one shot. But mentally even, but you want to, you don't want to make any mistakes right now. So just follow like the PEMDAS thing. It's best for now. Yeah, for now. But yeah, okay. Is that okay? Look, sometimes some people actually will parenthesize the 2 to demonstrate that I only did the parenthesis, but technically if you do the parenthesis, it should go away. They should go away, right? So that's why I don't copy that, but sometimes they do. Yeah, so anyway, I think you're okay. So parentheses done, so I check. You can cross it. Now exponent, here we go. We're doing exponents next. See, XE for next. So we do exponent, that means we're going to do that. 2 to the third power, that becomes 8. It's the same thing as, let me kind of bubble this to show you how I got that. It's 2 times 2 times 2, because 2 to the third. So 2 times 2 is 4, 4 times 2 is 8. So if you can see it. That's why
yeah.
it's 8. And then I copy everything else around it. It's very redundant. I don't like it, but it's something that you kind of learn to do at first. But later on, again, you can do simultaneous work like multiplication, division. But right now, let's don't do it because your teacher won't like that. Okay, now you're done with the exponent, but this time you're going to do this again, multiplication or division, whichever comes first from left to right. So you're going to have to do it. So read from left to right again, scan from left to right. Division comes first, so you should be doing that first. So don't forget, MD can be switched around. AS can be switched around, but that's why I'm doing division first.
But
So
like not like D and S though, right?
D and yes, you don't want to do that because the division happens to come first. Look how I see this thing, right? The DS. I put like an arrow on like this. It means that I can switch them into D, M, or S, A if you want. You see? But I just eye it. You can switch them. But when we switch them, well, it depends on how they arrange the problem. It's like every time you do something, you scan from left to right again. If you scan from left to right, instead of you seeing the multiplication, like the M first, you see D for division. So you got to do that first. So that's the proper way of doing it. Is that okay? So yeah, let's do that. So we do division before multiplication. Technically, let me explain. You could be doing multiplication. Later on, you'll learn that you can do this, whichever operation first. However, the teacher will not like it because you're not following the rule, right? But later on, you'll see that you can do it. But get comfortable with doing this first. Trust me, it'll be better off. So you don't make any weird error. It can happen. But anyway, division first. So it looks like this. You can do long division on the side. 3 can go into 4 one time, subtract 6 for 18. So it becomes 16 here. So 48 divided by 3 is 16. Remaining 0 right there. Then you copy. So I'm done with that, I bring 8 down. Okay. And then we do the multiplication. 16 times 8 for the last, only thing you got left. So 16 times 8 on the side here. So it's 128. The 128 is the final answer. But have a look, okay? I'm going to check this work right now. So something like this you can always do if you're not sure if you did it the right order. Hey, don't forget, if I punch in the scientific calculator, the division symbol is a slash. So there it is. Times is like a asterisk, let's star, parentheses, minus 1 raised to the third power. Okay, have a look. So 128, there's your answer. So that's the proper order. But later on, you'll learn to actually do whatever you like. But you can only do this if there's only division and multiplication left over. Okay, after you don't see anything else, or clumped together as a group, and whatever else around, like adding, subtracting, you technically can do this first. Like the group first, any order. You'll see right now is it's like, well, what am I talking about? But anyway, yeah, I'm doing PEMDAS exactly the order that I should be doing. So I'm following it to the T. Okay, number 9. Let's do 9. Same thing, but let me copy it, subtract, and check this symbol for me. That's a division, right? Like the 4 to the second power and divided by 2. Is that right? Between the parentheses?
Yep.
And what about the last one? Is that adding or division or dividing?
Adding.
Okay, so it's add 17 like this, right? Double check. Is this right? Divide, add right there. Is it okay?
Yep.
Okay. All right, now PEMDAS again. I'll write up here. Okay, so we got to do the parenthesis, what's inside the parenthesis first. Now, this is a really good problem because inside the parenthesis, it's like a new problem on its own. So if you look at between the parentheses right now, you got exponent and division. Look at exponent and division, right? What should you should be doing first? You got to do the exponent first. It's like this, yeah. It's like the PEMDAS reset. It's reset almost every single time. Everything you do, you reset. Okay. So that means in between the parentheses, because you're doing P, you should be doing the exponent first because it's like a stronger operation that you should be doing. You'll learn this through experience. You know exactly what you should be doing first, but you got to do you got to follow that PEMDAS, which it's lame. 16 divided by 2. So this is what you should be doing and copying everything else around with the parentheses. Even it's like you're not fully completed yet. So I'm going ahead and copy everything else around it as is. So here it is, so far. So I'm still working on P, so it's not yet done. So working on P, I could only do exponent because it's stronger operation. You can think of that way than division. That's why I did it first. Besides, it's near the 4. You see that? It's nearest to the 4. I mean, I can't be dividing this. Where's the 2 going to go, right? The exponent 2? That's why you should be doing it. Anyway, continue on. Reset. You can do P again. So once you do P, take out the parenthesis. Some people don't take out the parenthesis, but you're done with the P, by the way. Okay. I know I said it earlier that I don't, for showing you guys, I take them out, but sometimes I do keep them for something else, for other reasons. But anyway, this gives you 8. So I'm done. I'm not going to write the parentheses just for you guys. So 50, I copy everything else around it like that. And then reset this. So I did the parentheses, reset. Then you scan from left to right again. If you notice, you have multiplication. Scanning, okay? See, based on this, you got to do multiplication or division, whichever comes first from left to right. So I come across multiplication first before I'll be doing subtracting and adding there, okay? So it'll be 40 right here. Then copy everything else around it. Minus, careful on this. You got to copy all the sign, everything else as is around it, like that. And so I'm done with multiplication division because there's nothing for that too. There's no division or anything. Anyway, adding, subtracting, whichever comes first. So I come across subtracting. So I'm going to subtraction first. I'm going to do that. It'll be 10. Then I copy out 17, everything else around it. Then final answer will be 27. There you go. Again, you can check it. I don't always want to do this, but I'll show it one last time at least. So 4 second power, divide will be slash 2, close parenthesis, times this asterisk, 5 plus 17. There it is, 27. Yeah. Okay. All right, good. Number 10.
Dude, my teacher, he assigned all these 27 problems for tomorrow.
Oh, okay. So that means you still have time to finish this. Is that right? Okay. Got it. Okay, so let's see. Number 10, it's interpreting like algebraic or verbal sentences. So yeah, it's something you have to get used to. All right, an art supply store sells posters for $9 each and picture frames for 15 each. Okay, fine. A, write a numerical expression for the total cost of 6 posters and 6 frames. So I think you can see how this works. You're gonna multiply the number of posters, which is 6 by 9, because that's the cost of each one. So it'd be 6 times 9 or 9 times 6. So I'll do 6 times 9. But the word and, you see and 6 frame, that's a plus. It's like you're gonna add 6 frame, but each frame is 15 each. So that means it's 6 times 15. So here it is, the expression that you should be writing for A. And do we compute? It doesn't say. I'm glad. Just leave it alone. It doesn't say that you have to actually, work it or get the answer out of it. Oh, yes, for B, you do. So you're gonna work it. What is the total cost of 6 frame poster? Okay, whatever. I don't understand why you ask us the heavy work on A and then just do like part of A for B. Yeah, you do B.
Oh,
So yeah.
Can you maybe like give me like the definition of a numerical expression?
This is the numerical expression. Expression means that it's a chunky thing that you put together with an operation in between, like adding, subtracting. By itself, like 5, whatever, this is a term. But when you times it by 2 or do something to it, it becomes an expression. So when they ask, hey, or more, you can not just times 2, you can add 1 or whatever. This whole thing is an expression. Or just 5 times 2, like this, it's an expression. Anything by itself is like a term, but if you do something to it, it becomes an expression. Do something to it, more or less, it doesn't matter. I'll go ahead and do this. This whole thing is an expression. So that's why this whole thing is considered to be an expression. Is that okay? So by itself, a number by itself is just a term or a number, but if you do something to it, it turns into an expression. You can think of it like that. Or
Yeah.
yeah, or you just go ahead and follow what they kind of want you to kind of put together, like A. That it will be an expression automatically. Grammatically, you can think of it grammatically. That's basically what it's implying for you to do. Total cost of 6 posters and 6 frames. There you go. So write numerical expression. It doesn't say get the answer or write the total cost. So you don't compute this. You don't multiply. You don't do PEMDAS on it. So that's what I see. Okay, that's how I see it for A. But B, you do have to do the work. It says, hey, what is the total cost for 6 framed posters? So it's just 6 times, what is each frame again? It's $15 each. So this is the only operation based on what I can tell for B. Yeah, so you're just gonna go ahead and multiply that and see what that's turned into. But I don't know about the total cost of 6 framed. Let me see, 6 frame poster. Hey, the 6 frame poster comes with the oh, it does. It's trying to trick you. Framed posters. See that? Framed posters. That means you're doing this whole thing. Tell me if you agree, right?
Yeah.
Yeah, you have to. Yeah, I thought it's asking only for the frame, whatever. I know. Yeah, so it's 6 frame posters. So you're gonna have to do the works. All right, I got it. Sorry, I'm not perfect here. So let's do the math. Order operation again for A, which is gonna be the work for B. So let's do. Let me write PEMDAS up here again. So no parenthesis, no exponent. So I'll just kind of slash them out. But from left to right, there are multiplications. There's 2 of them before I do adding subtracting. So I have to do this 2 multiplication. Here it is. You can do them simultaneously. Okay, I'm going to do it here. 6 times 9. What is 6 times 9?
54.
54. 6 times 15. What is that? There's a bunch of pair of 30s, but okay, I'll use the calculator. You can multiply on the side, okay? So it's 90. And then just add them together. Oh, the reason I add them because I'm done with multiplication and there's no division, so I'll just slash them out. Now I come across from, adding, subtracting. Let's just add. What is that? 144. There you go. Again, you can always check the work if you want. 6 times 9 plus 6 times 15. 144. There you go. Nice. Total cost. Oh, this is a word problem. You may want to put a dollar symbol here, like in front, or the word dollars in the back. Something like that. I don't have to be thorough a little bit. Sometimes I forget. Number 11. Okay. There are 24 students in a science class. Mr. Sato will give each pair of students 3 magnets. Okay, I'm kind of imagine that. So far, Mr. Sato has given 9 pairs of students 3 magnets. Okay, it's getting pretty fancy, by the way. How many more magnets does Mr. Sato need so that each pair of students has exactly 3 magnets? Okay, you want to think about this away from the PEMDAS stuff or order operation. Want to think about it? It's kind of fancy, but it's actually something that similar to what is that problem? The hot dog problem. How about that? Pretty fancy stuff, but I think you can handle it. What do you think? There are 24 students, right? And each of students, 3 magnets.
Is it 15?
How do you get all that? I mean, I think you have to do some kind of order operation, right? So, for example, there are 24 students, right? To get a pair, you can divide it by 2. Let me see if you're okay with this. For example, there's 24 students divided by 2, I get 12 pairs. I want to know how many pairs of students there are. So therefore, it's 12 pairs so far. Is
Oh,
that
wait.
okay?
I think that's wrong.
Yeah. But you see how I got that? Yeah.
Well, does the pair have to be 2?
Yeah, it has to be 2.
What
Yes.
what implies it that it's 2?
Well, I mean, this is just
Oh,
yeah. To me, it's just grammatical. It's just each pair right there. It emphasized each. See that the word each and the word pair. I'm pretty sure. I'm pretty sure that's what they want. But yeah. So, but then how many magnets? Well, 12 pairs. That means 12 times 3, right? Give you 36 magnets. So forth.
uh-huh.
But you're not done. 9 pairs of students. Okay, right here. So far, Mr. Sato has given 9 pairs of students their 3 magnets. But how many more students? I'm sorry. How many more magnets does Mr. Sato need so that each pair of student has exactly 3 magnets? Okay. So what do you think? 9.
Uh,
You need. There are 9 pairs. 9 pairs. 3 magnets. So you should be doing the 9 times 3. Is that okay on the side? Is that okay? So you can actually see how much more you need. Is that okay? Look at that last part. 9 pairs of student times 3. This one they gave you 9 pairs, 3 magnets. So therefore you got 27 magnets for those 9 pairs. This is actually too fancy for you to write it as an like that long string, like those problems up there, like the one that you did with the order operation with the PEMDAS. Right now, they don't ask you to write it out like that. So they ask you to break it down, or they implied you should be doing that because I think it's too challenging for you to write them out like as a long strings of operation. So that's why you can just write however you want, like tabulate what you're going to do, whatever, like step by step. So I think this is best in my opinion. But then you subtract them. That's why you do the 9 pairs so you can actually see the difference between them. And that's it. 36 minus 27 should be whatever that is your answer. So this is how I see it. But you technically supposed to be writing this later on, I guess, not now. Like number 8, number 9, number 6 up there. But I think it's too challenging. It's too long. I'm sorry. The way this whole made up story. But that's it. I'm pretty sure this is whatever this is. What is that? 9? So yeah. So you need 9 more magnets. You need 9 more magnets. But you can write 9 as the answer. But 9 more magnets. Yeah,
cool.
copy this down. Hope that makes sense. I think it makes sense right after you see this, right?
Yeah,
I
yeah.
think you follow. Yeah, I'm pretty sure. But yeah, but it's based on that particular long strings of operation that you should be doing, but it's worded in a story, whatever. But anyway,
Okay.
number 12, 9 more magnets. Oh, wait, 12. The evaluate or just basically multiply or add and subtract like
Do you have
whatever
to
operation. I'm sorry. Yeah,
solve it?
yeah.
Yeah, okay.
You have to substitute the variable. Well, number 12 is just m. Sometime too, you may have to do both variables. Oh yes, number the number 16 to number 19, you do both variables. But this one just one variable at a time. So I can just show like this. I won't copy the original. I'll just go ahead and substitute or plug in the m with 6, and then I dot 4. So and then operate. So multiply. So the answer is 24 for 12. 13. Oh yeah, there is 2 right there. Too small for me. I'm old, dude. So it's going to be 6 times 12 here. 6. Oh, is that divide? Sorry. Is that add?
No,
Number
it's
13.
add. 13 is add.
Add. Okay, so add 12. So I'll be 18. 14. 36 minus 6m. So 6 times m. So 6.6. So order operations say, hey, don't add, subtract until you multiply, divide. So you got to do this one first. So it becomes 36 here, right in the back, and then copy everything else in the front, including the sign, exactly where they are. So the answer is 0 for 14. Careful, yeah. Let
Okay.
me double check. Yeah.
15.
15.
3 times. And
3 dot, I would do dot 12
36 plus
plus 8. Is that okay? Yeah, 3 dot 12. Yeah. So it's 36 plus 8, whatever this is,
44.
44. Yeah, or 15. Very good. And then continue 16 here.
How do you make this?
Okay, this is a good one. You haven't been taught to simplify like complex fraction, like a fraction inside a fraction yet. So, but you can, I'll show you, it's not that bad. So you can still write 10 bar, but I don't know, boldface that. So that is like the main bar that came originally. And then write the 1/5 below it. I know it's weird. This is called complex fraction in later math, but you don't have to worry about it. But then you can, yeah, right now you don't have to worry about it. But the way that you interpret this is like this 10 divided by 1/5. Does that make sense? Yeah.
Uh,
Yeah,
yeah,
that
that makes
bar, the main bar is division. Then do the math that you know how to do. You flip flop, the second number or fraction, and then multiply. So it'll be 50 over 1. The answer is 50. Double check. Yeah.
mhm.
10 divide. Yeah, that's it. Yeah, I don't know. They already gave you like a fancy fraction. I never seen it at this level. It's pretty cool. I'm glad. I'm glad that, yeah, they're previewing. They're giving you what you should be doing later on. All right. 15C means 15 times 1/5. You can cross cancel here, but I'll copy everything else first before I do that. Plus, is that plus? Yes, right? It's plus B.
Yeah.
plus, yeah, plus B. B is 3. B itself is 3. And the 3 is raised to the third power. Double check. Yeah. Okay. So 15 times 1/5, you can put a 1 underneath. 5 can go into 15 3 times, itself 1 time. Multiply straight across, you get 3. 3 times 1 is 3 over 1. Ignore over 1. Just copy 3. And then plus, oh, Barbie said, hey, shouldn't you be following PEMDAS? Guess what? I actually broke the rule. But this is based on experience, meaning that you realize that you can do simultaneous work. I have done that right here. What does that mean, simultaneous work? You work everything else around adding, subtracting. You can do whatever you want. Here it is. So here's like a little trick. If you ever want to speed things up, PEMDAS, you can ignore it if you want. Well, actually, not entirely. All you need to do is do everything else before you add or subtract, especially adding, subtract. I'm sorry, especially multiplying or dividing. Adding, subtracting, do them last. So that's why hey, if I wanted to follow PEMDAS to the T, I should have been doing the D to the third power first. I didn't do that. But I know I don't have to because, yeah, with time, you realize that PEMDAS, you don't always have to follow it. So I didn't follow it. I went and do the multiplication first, but it's okay. But pretend that you follow it, right? So, okay, if you follow it, there is no P. Exponent, that'll be 3 times 3 times 3. Let me kind of show the work here. 3 times 3 times 3. That's going to be 3 times 3 is 9. 9 times 3 is 27. So if I did that, I would be copying this in the front anyway, but I still have to do that or turn into 3 in the front anyway, right? That's why I did that first. But don't worry. You can write 27 and copy this chunk and then work it and you'll still get 3. See? Yeah. But anyway, this is what you have left, and then just add. It'll be 30, final answer. Yeah. But okay. All right, continue here.
So 30 plus 9.
No. Wait, do you want to see it? You want to see it? Yeah, it's
Oh, wait, yeah, I see it.
it's let me double check. 17. It's 15 dot C. 15 dot C is 15 dot 1/5. Is that okay? So 15 times 1/5
Yeah.
is 3, yeah. And then plus 3 to the third. Okay, let me see.
Okay.
Hey, I'm gonna have you try to do the rest on that section. I want to do 20. Is that okay? Let me do 20.
Okay.
So scroll up a little bit, please. Let me see. And 21. Yeah, I think I think you can do the other ones. They're not too bad. Let me help you with this here. Okay, 20 animals. I don't know what this is. Gin 2 or Gin 2 penguin can swim at a rate of 17 miles per hour. How many miles can penguin swim in 4 hours? Use the expression R times T. RT means R times T, where R represents the rate and T represents the time. So 20, I recommend you write RT right at the top, and then below it, R stands for rate, and the rate said is 17 miles per hour. You don't need to write the unit, just 17. So R is 17. T, if they're written next to each other, RT, it implies multiplication. It's multiplication. RT, R times T. So it's 17 for R, and then the T, it says T will be 4. That means you bring down the T being 4, and then you multiply. So this is what you'll be doing, whatever this is, okay? So I'll let you do the math there, and the unit for that will be in miles. Done. Okay, now I want to do 21. Let me see. A company charges $6 to make a pattern for an order of t-shirts and $11 for each t-shirt it produces from the pattern. Okay, whatever. The expression 11n plus 6 represents the cost of n t-shirts with the same pattern. Find the total cost of 5 t-shirts with the same pattern. Okay, so what they're doing here is not that big of a deal. They're teaching you that, hey, that 11, I know I didn't read the dollar symbol, but ignore it because I think it's simplest. 11n plus 6. I know it's $11 and $6. Normally they don't put that in there, by the way. It's very rare. Anyway, that 11n plus 6 represents that first whole sentence, that whole statement up there. So they're kind of like interpreting 11n plus 6 as a story. So that whole source sentence represents 11n. So I'll write it down. 11n plus 6. That's all you need, by the way. So that whole mumbo jumbo is 11n plus 6, the first statement. But they gave it to you. In the future, you have to come up with this expression right here, the 11n plus 6. But they gave it to you in this one. So you get to use it. So the only thing you have to use it for is for the last part right there. Find the total cost of 5 t-shirts. So the n, see, the n is the number of t-shirts. It says right there, right somewhere there. I think the cost of n t-shirts right there. So it's implied that n. So anyway, the math that you do is 11.5 plus 6. That's all you need to do for this problem. So 11, order operation says multiply before you add. So it becomes 55 plus 6. So that, let me see, the final answer. Oh, don't forget the final answer is going to be in dollars. So what is that?
$61.
$61. Yes. So easy. So, okay, let me do 22 quickly. So 1 second. Let me tell my other student quickly. Okay, so
I think I'm okay. I think I
okay,
know how to do this.
but let me write it out. I believe you do. Yeah, I believe you can handle this. But let me just do it quickly. 22. Define variable. Okay. Yeah, I want to do at least a couple here. Define means you have to declare, or yeah, they call it define. You can declare it. How? For example, number 22, 9 less than a number. You can say something like this. Let n equals a number. No kidding. Something like this. I recommend you do it. But I'll do one more so you see how you can actually define a variable. So I defined it right here. And then you're going to use it in an expression. You can come up with an expression. So 22 says 9 less than a number. So you write minus 9 behind it. Careful on this one. Don't do 9 minus n. It'll be wrong. You have to take it out from the back. Number 22 is actually, I think, maybe the most challenging. Even though it's really short, a lot of students make mistakes here. When anything says something like a number less than something else, you always put that number behind it. 9 less, 5 less, put it behind. So this is the correct expression. This is the right answer. If you ever put 9 minus a number, it will be wrong. Careful. So this is a common error. So number 22 is right. They gave you like the trickiest one right away, just to have you mess with it. See what you can do. Okay. So 23. Let n again. I know this is redundant because it's still relating to a number. So let n equals a number. Some people write x. X equals a number. I'll use n because it's more common. Let n equals a number. I'll do it again. This is define a variable, okay, right here. So let n equals a number. 5 times a number. So 23 now, okay? 5 times a number, so it is 5n. Is that it? 5 times a number of book. That's it. Okay, whatever, that's it. Anyway,
B times 5, because I did B for books.
Okay.
Oh, wait.
Okay. Yes. Okay. I'll let you dictate this. So that means you have to come back up here and say, let B equals a number of books. Is that okay? Yeah. Go ahead.
Yeah.
It's okay. Yeah. Go ahead and modify the what is that? The defined variable part. Let B equals a number of books. So then you have to say 5B. 5B. Is that okay? 5B. 5 times 9. Yes. Good job. I like that.
Why didn't you put B times 5?
You can. Yes, you can.
Oh.
Yes, you absolutely can do that. Or b.5. Now, it's more common with the number in front of the variable. You'll see it later on, but your teacher will accept that. Yeah, you see it's more common to write the number in front of the variable. It's standard. That's more standard. Okay, 24. 3 more pancake than his brother ate. 3 more pancake than his brother ate. That means you want to say P plus 3. So this whole thing, yeah, you can say P is the number of pancake. Let P equals the number of pancake his brother ate. His brother number of pancake his brother ate. Something along that line. P is the number of pancake that his brother ate. Is that right? 3 more pancake and his brother. Anyway, number of pancake. Number of pancakes. I think it's safe. Just write that. But the answer is P plus 3. 25. 2 more than 7 times Lin's age. So I'll do A for H. 7 times Lin's age is 7A. 2 more. You can put 2 in the front, but this is more common, okay? 2 plus 7A or 7A plus 2. But you have to say let A equals the number, equals H. How about that? Make it short. Let me double check.
Okay.
2 more than 7 times Lin's age. Yeah. Lin's age. So let A equals Lin's age. Lin's age. That's it. 7 times 2. That's it. We're all good. Is that it? 25? All right, Noah.
It's 27.
Oh, wait, let me see.
These are
26. Let me see. 26. A plumber charges 50 to visit plus. Okay, easy. Let me write the answer for you. So it's going to be 40 times x plus 50, and then you have to let x. This one is important. Everything with the word let, the phrase let, please copy them. Okay, I'm gonna actually underline them. All this that I write, you have to do it because it's just to declare. Let x equals the number of hours. Number of hours. So let me double check. That's it for sure. But you have to write. Yeah, 40x plus 50. Yeah, 50 is the fixed price that you have. They're going to charge you no matter what. But from there on, every hour, number of hours. That's right. They're going to charge you 40. Does that make sense? Like, yeah, if you think about it, yeah. If you do 1, you're going to add 40 times 1 plus 50. 2 hours, 40 times 2 plus 50. There you go.